Okay, let's get started. So, this is going to be about maps and slices. We've looked at slices a little bit, but we're going to go into a little bit deeper detail on slices today, and we'll look at another type called maps. As usual, created a directory. I opened it in Visual Studio Code. I ran go mod init, and my kind of placeholder name right now. Certainly this doesn't have to be dark ink. It can be whatever you want it to be. You can sign up for a GitHub account and call yourself Molasses, and this would be github.com molasses get going 06 or whatever you want to name it. But having a module does make life easy for certain things. So anyway, let's put this in a main package and build our main function. Okay. Um, let's start with a quick recap on slices. So we know how to create a slice, right? We create a slice literal by saying names equals um, so we can say create a slice of names like this, and here we have the type of the thing in the slice, right? And we've got 3 elements, and if we say print the slice, we go run this, we see we have that slice of names. Okay, great. Um, of course, we can add to a slice. We can say names equals append names and a new name, Robert. Now if we run this, we see that it is Robert as appended to the slice. The reason we have to do names equal is this returns a new slice that is composed of Joe, Jane, Alice, and Robert. While if we didn't have the names in, we wouldn't capture that new slice. Let's call it other, and printf. We'll go ahead and print out other. And by the way, every time I go to run this, I do a save, a Command S for Mac OS, but Control S for Windows. So I can go ahead and run it from the terminal. So we have append creates a new slice. So here we have the old slice isn't changed when we do an append. And we have a new slice with the data appended. Okay. So let's say, for example, we know we wanted a slice of names. And let's use the complete, let's take for a second, take a look at the complete declaration. So var names, and the type is string slice equals yep, don't want that there. There we go. So that's the full declaration. But anyway, let's get rid of that for a second. And let's say we have names. And we know we're going to have 5 elements in the slice, but we don't know what those elements are yet. So we can say make, and we give it the type of slice, so it's a string slice. And we can give it a size. So we know we have 4 elements, say for example, and once we do that, we can say names 0 equals Joe names Jane names let's see, JJ Ellis, and names 3 equals Robert. And if we, again, I hit save every time I do that, and I go run this code, there we go. What if I hadn't done this? What if I had just said, make me a slice of strings? If I try to run this code, it will fail. So if I go run, I panic because this is an empty slice. And so it has a length of 0. And I can't just index into, it doesn't even have a first member. It doesn't even have a name 0. So I can't actually set a value in a slot on a slice that is empty. So that's why in this case I would want to do make. And again, if we go over on this, it's fine, right? So let's print out some other stuff on the slice. So a slice has two attributes of interest. So we've got the built-in function make. We've got the built-in function len, which gives us the length, the number of items in a slice. And we have another one called cap, which gives us the number of things that could go in the slice before the slice is reallocated. So let's go run this. Okay, we see that the length of names is 4. We have 4 elements in the slice, and that's what we made. We made a slice of length 4. And it has a capacity of 4, and it only allocated a capacity for that slice of 4 because we were only asking for 4 elements. Let's say, for example, I knew that I would have at least 4 elements, but I could have more. So let's take a pause to understand a little bit what happens with slices. Slices have an underlying array, and I haven't covered arrays because arrays are a little bit specialized in Go programming, and generally, to get started, you won't need arrays, and you can learn arrays in 5 seconds after you've learned slices. Unlike slices that can be increased in length, arrays are fixed sized for their life. So if you want to allocate a new array, you have to destroy the old array and create a new one that's bigger. And this is relevant for slices because a slice has an underlying array in which it stores the data. Now, if I ask, what happens if I add another member to the slice? I want to append. Let's add Brian to the array. Oops, don't want a colon equals, just want an equals. And let's print this information. And actually, let's go ahead and do this. Len equals so if we do this, we see that now, after we've added Brian, the length is 5. That makes sense, right? We have these 4 names. Then we added Brian, so we've got 5 names. That's fine, length of 5. But now the capacity is 8. Okay, does that mean we can just add an 8th member or another member? Names. So that's 1, 2, 3, 4, 5. The 6th member will be number 5 because we start numbering at 0 and not 1. Equals Lilith. And what happens if we try that? Again, we're out of range because even though we have a capacity of 8 now. Let's go ahead and add this. Even though we have a capacity of 8, so we see here with we've got a length of 5 and capacity of 8. We don't have access to those additional members because we haven't really told the slice that we want to access those things in the slice yet. As far as the Go is concerned, the slice is of length 5 here, and when we try to add a 6th element, we're overrunning the end of the overrunning the end of the slice. The difference with cap is basically saying, okay, I won't reallocate a new array underlying the slice until you try to add a 9th name. And this is important from a code performance standpoint. So if you knew, for example, that you wanted to have possibly as many as 16 names, but most likely starting with 4, you could make a second number, which is the capacity of the slice, and that's just how many items are added or available in the underlying array before that underlying array to that slice gets reallocated to give it more space. If we run this, we see that, oh, let's get rid of this line which caused it to crash. And go clear. Oh no, the little trash can icon to clear it. Whoops. You terminal. Okay, so we see that we here now have a an array, sorry, a slice of length 4. The underlying array has a capacity of 16 elements, and we're only using 4 of them right now. We can append something, and when we append it, we still have an underlying array of 16 elements. Once we add that 17th element, we'll get a new underlying array with usually twice as many elements before it has to reallocate. And the only reason I wanted to cover capacity or cap is because you will see it in code, and I don't want you to get confused to think, hey, I've got 16 things. I can go ahead and start accessing all 16 before I've appended it or lengthened the array. No, what you've got is a slice of length, I'm sorry, I used array where I meant slice. What you've got is a slice of length 4 with an underlying capacity of 16, but until you actually append that 5th element, it is still a slice of length 4. Okay. All right. Now, let's move that into its own function. We'll call that func slice stuff. Okay, and down here, we're going to go ahead and look at maps. So a slice is a list of things indexed by an integer. So we say, give me the 4th element of a slice, right? What if we have the following situation? I have high scores, and I want to look at the high score by name. Well, excuse me, Go has the concept of a map or hash map, and we use the make built-in function to create one. And so we're going to create high scores, and we are going to go ahead and say it is a map of strings that maps to integers. Okay, we're going to call make with this. So it is a map of strings to integers. And we can say Jane has a high score of 20. High scores. Bob has a high score of 18. We can go ahead and print it. And so we see our map. It's a map where Bob has maps to the value 18, Jane maps to the value 20. So one big difference is slices are ordered. So throughout the slice, unless I change the slice, Joe will always come before Jane, will always come before Alice, will always come before Robert, will always come before Brian. They are ordered and they're fixed in their order. Maps are not. So I could put the maps, the values into a map in a given order, and when I go to get them out, they can come into any order. So we've got make to create a map. We can also create a map with a map literal. String int, again, we say what type of map it is, and we say Bob. We use a colon and a number. Jane, colon, and number. In this case, we're using a number because it's the string, and the string maps to, that's why it's called a map, an integer. 20, Alice, 22. Okay. And again, if we have more than, if they're not all on the same line, if we have them across multiple lines like this, the last line has to have a trailing comma. And if we run this, again, it happens, we put them in the map in the order Bob, Jane, Alice, but they're printed Alice, Bob, Jane. Okay. Unlike slices, we don't have to worry about length and capacity with maps. We can just simply say, let's see, Joe. Joe has a high score of 23. And remember when we tried to add an element to a slice without first appending it to the, or without, when we tried to add an element to a slice that was beyond the length of the current slice, we got an error, even if we had enough capacity, unless we appended it, right? That is not true for slice. That's not true for maps. So if I run this, I see Joe has been added to the map. Fine. I don't need to do an append like I did here to add an additional element to the slice in order to add that value. And on the map, I can just say here's Joe. Finally, we can start. I used make, but also we could just use an empty map literal and just say high scores, Jane. Equals 18. So if we go run this, there. Okay, so we've covered make and its use with maps. What happens if we declare a map without anything in it? So if I just declare var high scores, which is a type of map of string to int, and I try to run this, you see I got the yellow squiggles, I'm going to get a warning. It fails, right? Because I haven't actually allocated a map. I'm only allocated a map if I make it or use a map literal. So let's make this code right again by saying I scores is a empty map literal. Now, that is different than a slice. So if I said slice, so if I said var names is a slice of string, I haven't actually allocated a slice here. What I could do, though, interestingly enough, is I'm sorry, I could go ahead and append, oops. So even though this isn't set to anything, it's nil. If you were to look at this value in the debugger, you'd see that names is nil. I can append to a nil slice, a slice that is of type or value nil, and start creating a slice. So let's go ahead and just for a second, let's go ahead and run slice stuff. And we'll remove this so we don't get confused. So we're just going to run our slice stuff, and we're starting with an empty or a nil list. So we start with an empty list. So nil is an empty list with a length and a capacity of 0. We add a couple of names, and we get now we have a slice with a length and a capacity of 2. And then we add a third name. So now we have a slice with a length of 3, and the capacity doubles. Whoops, this should say cap. The capacity doubles to 4. Okay, so we've seen how to do the basics with slices. Let's get rid of slice stuff now. Don't need it anymore. So let's go back to maps. So high scores equals map string to it. And we'll create an empty literal. Oh, it needs to be colon equals since we're allocating a high scores. Again, to add a value, we say high scores, and then a new key, Jane, 7. We can add another one, high scores, Bob, 32. Right. What if we didn't want Bob in there anymore? We can say delete, and we give it a map type and a map key. So the map is high scores, or map and a map key, and we want to get rid of Bob. And then let's print out our map again. So here we have Bob and Jane both in the map, and here we remove Bob from the map. All right. Let's talk about one more thing, which is iterating through maps and slices. So let's start with names. And we're going to create a slice of names, and Joe, Jane, Bob. And we are going to iterate through them. So for I equals range names, thumped println hello. Oh, that needs to be printf, not println. Okay, so if we run this, we see we iterate through each name. Now, this I is the index. So this is giving us for all the valid indexes in the slice, which would be the numbers 0, 1, and 2. Let's actually print that. Let's say %d, and we'll add I in there. If we go run it, we see for each index we get the value. Now, sometimes we don't want the index. We don't care that it's at position 1 or position 2 or whatever. We just want we just want the value. Well, by default, range gives us the index, we can add a second parameter here, which is the value. So rather than saying names at I, instead of looking it up, I can just say print the value. Now if I run this again, I see the same thing because now I've got I is bound to the index and V is bound to the value at that index. And if I don't want the index at all, so I don't want to do anything with the index, I don't, I just want the value, I use an underscore here to throw away the index. Okay. What happens if we have a map? With a map, we have high scores. And we're going to say Joe has 18, Jane has, excuse me, 20, Bob has 19. Okay. Now, if we want to iterate for I is equal to range high scores, what is I? So let's mouse over I and see. It is the string. It is the key. So just as we got the, just as this form gave us the index into the slice, this gives us the keys into the slice. So if we ran this and we wanted to print the high score, we would need to print that key. And normally, instead of using I, we use K for key. So you'll see that in a lot of Go code. So now if we want to iterate through all the keys, Joe has a high score of 18. And the same thing, if we want the values, we can add a second parameter, and that gives us the values. So again, now we have the index, so the name Joe, Jane, and Bob are mapped to this variable, and the values 18, 20, and 19 are mapped to this value. Okay. What if we try to look up something that's not in a map? Well, if it's something that's not in a string, we're going to get an error, right? So if we say thumped printf, and we say names, and we want the 28th element in that list, what happens? We get a panic because we tried to access something from beyond the length of the slice. Fair enough. If we try to get something from the end of the array, for beyond that's not in the array, so for example, let's say thumped and we want to say high scores Lilith. We go run this. We see that, let's make it more obvious. We get the 0 value. So it's perfectly fine to ask a map for something that's not in the map. We get the 0 value for that element. So we got the 0 value for int, which is 0, right? There is another form where we can say get a Boolean indicating that it's not that Lilith had a 0 score, it's that Lilith's score is not in the map. So we can say okay, score is equal to And we're going to ask for the thing that's not in the map. And if, okay, so if we got a value, sorry, I got that backwards actually. Score, okay. Sorry about that, I had that backwards. So if, okay, so if we got a value for Lilith's score, Lilith let me just print the score, else, and this could have actually just been print ln. We use printf a lot, but if you're not sending any values out to be printed, you can just use print ln. So in this case, if we get back a value for Lilith's score, okay will be true, and the score value will be set. Otherwise, we expect the score to be the 0 value for integer. So if we go run this, we see that, in fact, here we got the 0 value for integer because Lilith doesn't have a score in the map. Here we were able to detect that Lilith doesn't have a score in the map, and we were able to fall into this block that said basically, hey, Lilith doesn't have a high score, Lilith needs to play. Okay, that covers maps and slices. I was going to do structs in this video, but I decided that I wanted to cover maps and slices first. I thought that would be of more utility in the immediate, well, no, not that. I wanted to do that before I covered structs to better show the rationale for structs. So again, we covered map and string literals. We covered adding and removing, we covered map and slice literals. We covered adding and removing elements from a slice. One thing I didn't touch on is what can we use as the key in a map. This is the key type, and this is the data type, or value type. So the key type can be anything that supports double equal and not equal. So that's basically your strings, your integers, and that kind of stuff. Functions, for example, you can't say functions are equal to each other, so we can't use like a function as a map key. But yeah, anything that can be tested with equality. Okay, so the next video I'm definitely going to cover structs, but that's it for today, and thanks for watching.